Today we will learn laws of exponents. In mathematics and science, it is often necessary to carry out various operations on exponents. To get the correct result of these operations, we need to understand the laws of exponents. In the previous class, we learnt that for non-zero integer a and b and whole numbers m and n, the following rules apply. Just think, will this rule also apply to numbers whose exponents are an integer and the base is a rational number? Think a little. Let's find out. The rule a to the power m into a to the power n is equal to a to the power m plus n will be the first to be discussed. Suppose we take the value of a as a rational number such as 7, the value of m is integer minus 2 and the value of n is integer minus 3. So the left side will become 7 to the power minus 2 into 7 to the power minus 3 and the right side will become 7 to the power minus 2 plus minus 3 whole is equal to 7 to the power minus 5. Let us find out whether the value of both the sides are equal or not. We can write 7 to the power minus 2 as 1 upon 7 to the power 2, that is 1 upon 7 into 7. Similarly, 7 to the power minus 3 can be written as 1 upon 7 into 7 into 7. We can express the multiplication of these two numbers as 1 upon 7 into 7 into 7 into 7 into 7's form. Since 7 is multiplied by itself 5 times in the denominator, we can write 7 to the power 5 in place of the denominator so that we get the number 1 upon 7 to the power 5, which can be written as 7 to the power minus 5. Now as you can see, the values of both sides are equal. That is, this rule is also true for integer exponents. In this way, we can say that a to the power m into a to the power n is equal to a to the power m plus n. This rule will also be applicable for numbers whose base is a rational number and the power is an integer. That is, it is true as a to the power m into a to the power n is equal to a to the power m plus n for a rational number a and integers m and n. Now let's talk about a to the power m divided by a to the power n is equal to a to the power m minus n. Here, if we take a is equal to 7, m is equal to minus 2 and n is equal to minus 3, we get 7 to the power minus 2 divided by 7 to the power minus 3 is equal to 7 to the power minus 2 minus 3. Let's find out whether the left side and right side are also equal here. For this, we will simplify the two sides and compare the results obtained. By simplifying the right side, we will get 7 to the power minus 2 plus 3 is equal to 7 to the power 1. Now we will simplify the left side. 7 to the power minus 2 divided by 7 to the power minus 3 is equal to 1 upon 7 to the power 2 divided by 1 upon 7 to the power 3. Can you tell how will we simplify this division now? Give it a thought. Let's find out. Do you remember that when we divide rational numbers, we keep the first number as it is, then replace the division symbol with the sign of multiplication and take the reciprocal of the second number. Here, the inverse of 1 upon 7 to the power 3 will be 7 to the power 3. This gives us 7 to the power minus 2 divided by 7 to the power minus 3 is equal to 1 upon 7 to the power 2 into 7 to the power 3. Since 7 to the power 2 is equal to 7 into 7 and 7 to the power 3 is equal to 7 into 7 into 7, we will deduct 2 7s from the denominator and 2 7s from the numerator. From this, we will get the result 7 to the power 1, which is equal to the right side. Here also it is verified that for the rational numbers a and b and for integers m and n, a to the power m divided by a to the power n is equal to a to the power m minus n. This rule is true. Now the rule a to the power m whole to the power n is equal to a to the power mn will be discussed. Suppose we take a is equal to 1 upon 2, take m is equal to minus 1 and n is equal to 2. Under the rule we can write 1 upon 2 whole to the power minus 1 whole to the power 2 is equal to 1 upon 2 to the power minus 1 into 2. Let's simplify both sides here too. We can write the left side as follows. 1 upon 2 to the power minus 1 whole to the power 2 is equal to 1 upon 2 to the power minus 1 into 1 upon 2 to the power minus 1. 1 upon 2 to the power minus 1 means 1 upon 2's reciprocal, that is 2. So we can write it as 1 upon 2 to the power minus 1 whole to the power 2 is equal to 2 into 2 is equal to 4. Now simplify the right side. Since both the sides are equal, it is verified that for rational number a and integer numbers m and n, a to the power m whole to the power n is equal to a to the power mn. Similarly, you can check the remaining rules. On checking, you will find that all the rules are true even for numbers whose base is rational number and power is integer. By knowing all these rules, we can easily solve the examples related to exponents. So we can say that for rational number a, b and integer m and n, a to the power m into a to the power n is equal to a to the power m plus n. A to the power m divided by a to the power n is equal to a to the power m minus n. A to the power m whole to the power n is equal to a to the power mn. A to the power m into b to the power m is equal to a into b whole to the power m. A upon b to the power m is equal to a to the power m upon b to the power m. A to the power 0 is equal to 1. Today we learned some exponent rules. In the next video, we will see some related examples.